jug jet. I think I've got the plans. I'll get a copy of this one for you too. But it's an old water cooler jug, and I'm using isopropyl alcohol or rubbing alcohol, about 20 milliliters or so. I usually don't tell students it's rubbing alcohol because they can go home and do this at their house. But what I'm doing is pouring the rubbing alcohol inside of the water container with nothing else in there. And I use just a plastic lid on there to start sloshing it around inside to help it vaporize. And I usually, as I'm doing this, I'm telling the students that it's not liquid that actually burns. That's not what's dangerous about the gasoline or any flammable liquids. It's the vapor. So if they're ever in a place where they can smell something flammable, don't light a match because that's where you get explosions from. So right now I'm coating the inside of this container as well as causing some of the liquid to vaporize. So it's saturating the whole container. And you want to do this for about 30 seconds or so, and just kind of up and down, side to side, back and forth. And just keep it going. And then I usually end it with tipping it like this, and if anything extra comes out, it'll form a nice little puddle on the side. That's kind of fun to play with as well, and I can show you that if we don't get any this time. So if you can't see the video, it's slowly oozing down the sides of the container. We got a couple drips coming out, so that'll be fun. Okay. And usually I get a nice big puddle. So for the sake of adding to it, I'll show you this real quick.
And the vapor will be a bit more dense than air, so it'd eventually pour out.
Exactly.
If it's not vaporizing anymore.
So, and then the other part of this, what I'm doing is I don't light it from this. I light it from a meter stick, so it's a little safer. We should get the lights too. This is a little safer, so it doesn't ignite in your face. So I just take a couple matches on there. There it goes. That's the jug jet part, and then the leftover that came out is lighting the desk on fire. And again, I usually have some stuff hanging from the ceiling to show convection, so the paper models will flutter around above it. But again, at the end of this, what's nice is you can show that it's not actually burning the desk. It's the vapors above the liquid that's actually burning. And so the heat from the flame is causing the flammable liquid to vaporize and then burn off in a combustion reaction right above the liquid. And then a cool part, I'll turn the lights back on for this, is that if you remember, we dumped this out the first time, but after the reaction, so in the combustion reaction, you get liquid again. So a lot more liquid comes out after the combustion reaction. And it's dirty. It looks, so that's where in a combustion reaction you get a lot of byproducts that are harmful to you. You don't want to breathe them in, so smoke from fires is not healthy, and then you can see this is liquid that you would not want to drink. But again, that's another kind of fun demonstration where you can see the chemical, or the combustion reaction inside of the jug jet. And if you put it in slow motion, you can actually see the flame start at the top and just kind of work its way down as basically a level as it's mixing with the oxygen in the fuel. So as the reaction is taking place and kicking the exhaust out and the flames out, oxygen has to get in there to keep fueling it. So you've got this exchange of air causing that jet sound. So it's kind of a really cool effect. So there's that one.
Awesome.